State the domain and the vertical asymptotes of this function. Okay, it's a natural log, and your basic graph of like just the natural log of x, this graph here is going to look like this. It is going to run along the y-axis, curve, go through the x-axis at 1, and then shoot off like this. It's actually the mirror image of the exponential function, but along the y equals x, like if you have like some base, let me use another color here. If you have a base raised to some power, that's an exponential function that looks like this. It runs along the x-axis, it curves here and then goes up. That has a asymptote that goes right through the origin. It's the perfect diagonal here. It's on a 45-degree angle. And it cuts. If you were to fold this graph along that gray dotted line, or that gray line, the blue graph would land right on top of the orange graph because they're reciprocals of each other. But we're doing logarithms, so the logarithm looks like that, the blue one. Okay? Now, logarithms can also be transformed around the graph depending about certain things. And because I have this, let's go green. I have this 5 minus x inside the parentheses. If there's a number hanging out with the x in the parentheses, that is either going to shift it left or right. And you will know what number it is because all you have to do is take the 5 minus x and set it equal to 0. If I add x to both sides, I get x equals 5. It is going to shift 5 units, positive 5 units. So that's going to go from here, 1, 2, 3, 4, 5 to there, which means my vertical asymptote, which was originally the y-axis, is now going to be at the 5. This is 5 because remember you were here, that was at 1. So 1 plus 5, when you land here, that's at 6. So my vertical asymptote is doing, or my logarithmic graph is doing this now. So the green graph is where I'm at. Now, there's one more thing that happens. Okay, because of the fact that you have a negative x, I'm trying to do that in pink, it's not coming out very well. Because you have a negative x, this thing is going to spin around your asymptote. And it's going to spin kind of like a weather vane vertically. So instead of it crossing here, it's now going to cross here, and it's going to run along the y-axis just on the other side and then go like that. So the blue graph no longer exists, and neither does the green one. It's the pink graph that is my final answer for this entire graph of the natural log of 5 minus x. This whole thing is that graph right there. And they want me to, type in the domain, and they also want the vertical asymptote. That vertical asymptote, there it is. It's that line I drew a minute ago, and it goes right through the y-axis at 5. So x equals 5. X equals 5 is the vertical asymptote. Mobius typed the x equals for you. You just stick in the 5. Now, they want to know what the domain is. The domain is all of your x's. And on this graph, which keeps going in this direction, remember every one of this graph is made up of an infinite number of points. But as you're moving from way over here, which technically is negative infinity, right? This way is negative infinity in the x-axis. So this point here has an x-coordinate of there. This point has that x-coordinate. This point has that x-coordinate. This point has that x-coordinate. I could keep going. But when I get here, these x's start to get closer and closer and closer to each other. They never cross over that line of 5. So my domain actually, let's go light blue, starts from way down here and comes up to this curve and then runs alongside of it. So my x's go from negative infinity up to, and then as close as it can get to 5. And you can see that's what I typed. Negative infinity, comma, to 5. That is my domain. And just to make sure I got it right, there you go.